Okay, so here's the second part of our solving systems of linear equations as matrices. And now we're going to look at a dependent system and what happens with that. Now, as I go through this, I'm not going to write those middle steps like I did in the first video. We'll talk through them, but I'm not going to write them out. So first thing, make sure you're in XYZ, XYZ, XYZ. We are. And write down your rows. Okay? And the first step, we haven't had to do this yet, but now we do, is to get a 1 in that first row, column 1. So how are we going to do that? Well, 3 divided by 3 is 1, or 1/3 times row 1. So 3 divided by 3 is 1, negative 3 divided by 3 is negative 1, 6 divided by 3 is 2, and 3 divided by 3 is 1. And then the next two rows stay the same. Okay, so next step, remember, is to get a 0 here and a 0 there. So the top row, we're done with it. We're going to focus on row 2. So how does a 2 become a 0? Let's subtract 2. So negative 2 times row 1 plus row 2. So here we go. Negative 2 times 1 plus 2. So, I got to think. Negative 2 plus 1 is negative 2, plus 2 is 0. Negative 2 times negative 1 is 2. 2 plus negative 4 is negative 2. Negative 2 times 2 is negative 4. Negative 4 plus negative 4 is negative 8. Negative 2 times 1 is negative 2, and negative 2 plus 8 is 6. Then we need to get our 0 on the bottom row. How do we make a negative 8 0? Add 8. So for row 3, we'll do 8 times row 1 plus row 3. So 8 times negative 1 is negative 8. Or, well, let's start with the first one. 8 times 1 is 8, and 8 plus negative 8 is 0. Already got that one. 8 times negative 1 is negative 8. Negative 8 plus 11, over here, remember, is 3. 8 times 2 is 16. 16 plus negative 4 is 12. 8 times 1 is 8. 8 plus negative 17 is negative 9. Okay? Next step. Get this spot to be 1. So row 1 is going to stay the same, and row 3 is going to stay the same for now. So what are we going to do to row 2 to make a negative 2 row be 1? Divide by negative 2, or multiply by negative 1/2. So 0 divided by negative 2 is 0. Negative 2 divided by negative 2 is 1. Negative 8 divided by negative 2 is 4. 6 divided by negative 2 is negative 3. And last, we need to get a 0 here. So the first two rows are going to stay the same. We're done with them. The third row, what are we going to do to it? 3 minus 3 is 0. So we need to take row 3 and first multiply row 2 by negative 3, add it to row 3. So here we go. Negative 3 times 0 is 0. 0 plus 0 is 0. That was easy. Negative 3 times 1 is negative 3. Negative 3 plus 3 is 0. That's what we wanted. Negative 3 times 4 is negative 12. Negative 12 plus 12 is 0. Uh-oh. We don't want that. Negative 3 times negative 3 is positive 9. Positive 9 times or plus negative 9 is 0. So this is where I said we are ending up with a dependent solution. We had this happen when we were solving systems in 2 and 3 variables before. So, what we've got so far is we've got x minus y plus 2z equals 1. And we've got y plus 4z equals negative 3. So we don't have any one thing solved. So what we need to do is pick one of the variables and make it our dependent variable. So what I'm going to do is take this second equation and solve it for y. So we've got negative 4z minus 3. Okay. Once we do that, if we plug it into the first equation, so here's the first equation. I'll make it a different color. And we're going to plug in our 4z minus 3. Negative 4z minus 3. And then simplify. So start by distributing. So we've got x plus 4z plus 3 plus 2z equals 1. And so now we can combine those z's to get x plus 6z equals negative 2. And we can solve for x. So x will be negative 6z minus 2. So now what we've got is if we just say that z is in any real number, then both x and y are in terms of z. So that gives us our solution. So here's how we write this. Granted, x, y, and z such that, that's how it's written, such that we have that x is equal to negative 6z minus 2, and y is equal to negative 4z minus 3, and z is any real number, which I like to write it like that. I wrote it differently in your book, but what this is z that is in the real numbers, kind of is what that says. That is our solution. So, we've now worked a dependent system with matrices. Now we're going to work an inconsistent system. I'm going to speed up a little bit more on our actual steps here. So, first we have 2, negative 3, negative 1, 0. Negative 1, 2, 1, 5. 3, negative 4, negative 1, 1. First step, we're changing the first row, not the other two. So I'm just going to bring them over, because in the first row, we have to get a 1 right here. So to get a 1 there, we're just going to divide by 2. So row 1 will be half of row 1. So we'll end up with, oh, wait a minute. No, that's not what we're going to do. Sorry. We're actually, it's going to make it a little bit easier on us, because if we do that, then we're going to end up with some fractions. So let's do something different here. Okay, so what we're going to do is switch row 2 and row 1. If we do that, row 2 comes in the first spot, row 1 becomes in the second row. Then we've got a negative 1 here, so it makes things easier for us, so that we don't end up with fractions, because that's all we need is to add fractions into this mix. Okay, so now how would we get just changing row 1 so that this first spot is 1? And the other 2 rows stay the same for now. Then we'll just multiply by a negative 1. So row 1 is negative row 1. We're just changing the signs of everything. Okay. Next step, we need to get a 0 here and a 0 there. So, to get a 0 in the first top spot, if we take row 2 and multiply row 1 by negative 2 and add it to row 2, then we should be good, because we're trying to change that 2 into a 1 or into a 0 by adding it to negative 2. So we end up with 0, 1, 1, and 10. And then for the bottom one, we're trying to get a 0 there. So row 3, to make 3 a 0, multiplied by negative 3 times row 1, add it to row 3. So we get 0, 2, 2, and 16. Oh, I've run out of space. Oh, crud. Okay. Well, let's do this. Oh, not that. There we go. Okay, so let's see. Remember, next step is to get a 1 right here. Well, we already got it. Yay. So that means we need a 0 on the bottom middle there. So I'm going to bring over the top 2 rows. And we're trying to get a 0 here. We'll still have a 0 there. So in row 3, if we want a 0 where the 2 is, then we will subtract 2. So negative 2 times row 2 plus row 3. So that gives us 0, 0, 0, and then negative 4. This is a problem. On the last one, we got zeros all the way across. That is okay. That means we have a dependent system. When we don't have zeros all the way across, this would tell us that z equals, or 0z equals negative 4, or 0 equals negative 4. That's not possible. So that means that this system has no solution, and we call it an inconsistent solution or system. 2 more examples. So example 9, we're taking this on to 4 equations. Okay, so let's get started. Still just got 3 unknowns, so we should end up with something that is okay with that. So let's write this down. We got 1, negative 2, 1, and 5. 2, 1, negative 1, and 0. Negative 3, 6, negative 3, negative 15, and 1, negative 1, negative 1, and negative 4. First step is always to get a 1 here. That's already there. We're good. So row 1 is all done. Okay, so we need a 0 here, a 0 here, and let's see. Trying to get us another color. A 0 there. Okay, so for row 1, or row 2, actually, how do we get a 2 to be a 0? Subtract 2. So negative 2 times row 1 plus row 2. That will give us 0, negative 5, negative 3, negative 10. How do we get this negative 3 to be a 0? Add 3. So in row 3, we're going to do 3 times row 1 plus row 3. That'll give us 0, 0, 0, 0. Oh, that's nice. Okay, we'll come back to that. And row 4, how do we get a 1 to be a 0? We'll just multiply row 1 by negative 1 and add it to row 4. So we get 0, 1, negative 2, negative 9. Okay. So what we want to do next is we want those zeros to be on the bottom. So all we're going to do is switch row 3 and row 4. So row 1 stays the same. Row 2 stays the same. Row 3 becomes 0, 1, negative 2, negative 9. And row 4 becomes 0, 0, 0, 0. Okay. Let's see. Now we need a 0 right, or a 1 right there. Notice something. We've already got a row 1 in row 3. So the easiest way to get us a 1 in this spot is to switch the 2. So we're just going to take row 2 and row 3 and switch them. So row 1 stays and row 4 stays, and 2 and 3 switch. So for row 2, we're now going to have 0, 1, negative 2, negative 9. And for row 3, 0, negative 5, negative 3, negative 10. Now we can focus on getting this spot to be a 0. I'll move things over a bit. Okay, so row 1 stays. Row 2 is good. Row 4 is good. We just need to change row 3 to get this spot a 0. So how do we make the negative 5 a 0? Add 5. So in row 2, we're going to do 5 times, well, that was row 3. So in row 3, we're going to do 5 times row 2 plus row 3. So we have 0, 0, and then, let's see, I've lost my place. 0, 0, 7, 35. Having a hard time grabbing this so close to the edge. And then we need this spot right here to be 1. So bring over row 1, bring over row 2, and 9, or 4. And for row 3, 1/7 times 7 will give us 1. So we have 0, 0, 1, and 35 divided by 7 is 5. Okay, so this is where we've stopped so far. But, and you can stop here. But I want to show you how to do reduced row echelon form. So we're going to continue to reduced row echelon. I guess some dude was named Echelon a long time ago. Form. Okay, to do that, we need zeros above the ones. Now, what's the advantage of this? You don't have to back substitute. So you'll see what I mean here in a second. So taking that matrix up in the top right, we're going to get a 0 here. And we're also going to go ahead and get a 0 here. So here we need a 0, and here we need a 0. So the third row, we're done with it, and of course the fourth stays just zeros. We could get rid of the fourth if we wanted to, but we'll just let it tag along. So in row 1, we need to get that second spot to be a 0. So if we do, we've got to change the -2 to a 0, so that'll be to add 2. So if we do 2 times row 1 and row 2 and add it to row 1, that'll give us a 0 there. So 2 times row 2, add it to row 1. Oh, this is supposed to be up there. There we go. So, because we've got a 0 there, we keep our 1, very important. And then 2 times -2 is -4. -4 plus 1 is -3. Then 2 times -9 is, 2 times 5 is 10, and 10 plus -9 is 1. Did I do that right somehow? No, let's try that again. I was looking at something else. 2 times, oh, it is row 2. 2 times -9 is -18. -18 plus 5 is -13. And then for row 2, we need a 0 in this spot. So if we multiply this 1 by 2 and add it, we'll get a 0. So we've got 2 times row 3 plus row 2. That gives us still the 0 there, 1, a 0, and then a 1 in this spot. We've almost got it. We just need a 0 here. So I'm going to go ahead and bring over the other rows. And we need a 0 in this spot. So what can we multiply by 3 to get a 0 there? Well, we can multiply the third row to get a 0 up here, right? So row 1 will be 3 times row 3 plus row 1. We still, doing that keeps our 1 and 0 in that first spot, gets us a 0 there. And then 3 times 5 is 15. 15 plus negative 13 is 2. So what has this gotten us? This has our answers already written out for us. So the first row says x equals 2. The second row says, since the 1 is in the y spot, y equals 1. The third row says z equals 5. So our solution is 2, 1, 5. So if you like doing steps on matrices more than you like back substituting, there you go. So example 10 says, Adam and Michelle require an additional $25,000 in annual income. They are rather risk averse, which means they don't like to take risks, and have narrowed their investment choices down to 3 different things. So they've narrowed down to Treasury notes, that yield 2%, Treasury bonds that yield 3%, and corporate bonds that will yield 6%. They have $700,000 to invest between these 3. Must be nice. And they also want, for some reason, the amount in Treasury notes to equal the amount in Treasury bonds and corporate bonds. So this is going to give us our 3 equations, okay? So first, the first equation is just the fact that N, that's what I'm using for, Treasury notes, plus B, that's what I'm using for Treasury bonds, plus C for corporate bonds. All those, when combined together, they've got $700,000 to spend. Then they have 2% in Treasury notes. So 0.02 times N. And then they're doing 3% in Treasury bonds and 6% in corporate bonds. And all that put together, they're hoping to get $25,000. The last equation comes from that last sentence where it says Treasury notes to equal Treasury bonds and corporate bonds. So N equals B plus C. We need to get that in the right form, so we just need to get B over and C over, and then we'll just be left with a 0 on the right. So the last equation is n minus b minus c equals 0. Now we can write our system. And we go through our steps. So the first step is always to get a 1 here, and we've already got that. So next is to get a 0 there and a 0 there. So the first row stays at 1, 1, 1, 700,000. And so the second row, how are we going to change that 0.02 into a 0? Well, we subtract 0.02. So for row 2, we're going to do negative 0.02 times row 1 and add it to row 2. That gives us 0, 0.01, 0.04, and 11,000. Then to get the 1 to be a 0, that's not as bad. So for row 3, we just need to multiply row 1 by negative 1 and add it to row 3. So that we get 0, negative 2, negative 2, negative 700,000. Okay. So, moving forward as quickly as possible, the next step is to get this spot to be a 1. So how will we do that? Take row 2, and if we divide by itself, so in this case 0.01, then that will give us a 1 there. So keep the first row, keep the third row, and the second row will be 0, 1, where is it? 4, and let me make sure I've got the right number of zeros here. 1,100,000. Okay, so we've got our 1. Now we need, guess what? A 0 right there. So, we're done with row 1. We're done with row 2. And we need a 0 in this second spot. So negative 2 plus 2 will give us 0. So for row 3, we're going to do 2 times row 2 plus row 3. That gives us 0, 0, 6, And then, let me check my number of zeros again. 1,500,000. Next step, get that to be a 1. So just divide by 6. Or row 3 will be 1/6 of row 3. Bring it right there. So top row stays. Middle row stays. And the third row and 1,500,000 divided by 6 is 250,000. So we could stop there and set up our system and back substitute. But I'm going to go ahead and get it in reduced row echelon form. So to get it into reduced row echelon form, we need a 0 here, and we need a 0 there. We'll need one there too, but next step. So bottom row is done. So first row, how are we going to turn a 1 into a -1? We'll do negative row 2. Oh, I first forgot. Plus row 1. And that'll give us 1, 0, -3, and negative 400,000. And then we need to get the 4 to be a 0. This stuff will stay 0 and 1, luckily. So in row 2, we need to do -4 times row 3 plus row 2. And that gets us 0, 1, 0, and 100,000. Last step, get a 0 there. So the second row is done. The third row is done. So for the top row, to get a 0, multiply row 3 by 3 and add it to row 1. So that we get 1, 0, 0, 350,000. And now we have our solutions. We know that there's going to be $350,000 invested in Treasury notes. There will be $100,000 invested in Treasury bonds. And $250,000 invested in corporate bonds. And that finally concludes the section on matrices. I know this was extremely long, but hopefully it provided you with the instruction you need to be able to do it.